So a complex fraction is an expression of the form, let's say 4 plus 1 over 2 plus 1 over x divided by 5x plus 3 over 2x plus 1 over 3 minus 4 thirds. So it is a fraction of fractions. And so let's do some examples, say from page 291. Let me do problem number 2. 2 thirds over 4 fifths. And so I can rewrite this as, and so in exercises 1 through 12, simplify the complex fraction. I can rewrite this as 2 thirds divided by 4 fifths, which is the same as 2 thirds times the reciprocal of 4 fifths, 5 fourths. I can cancel. 4 divided by 2 is 2. And so 1 times 5 is 5. 3 times 2 is 6. Let me do problem number 6. And so, well, actually, let me do problem number 8. Negative 3 fourths over 3 eighths. So let me rewrite this as negative 3 fourths divided by 3 eighths, which is the same as a negative 3 fourths, times, and so I can rewrite division as multiplication by the reciprocal. And so I'll rewrite this division here as multiplying by the reciprocal of 3 eighths, 8 thirds. And I can do some cancellations. The 3's cancel. 8 divided by 4 is 2. And so I have here a negative 2 divided by 1. And so I can reduce this, simplify this to a negative 2. Let me do problem number 6. And so 1/2 plus 2 thirds divided by 1/3. Let me do this a slightly different way. And so let me multiply both the numerator and denominator by the least common denominator, which in this case is, well, there are a whole bunch of denominators here. There's 2, 3, and 3, so the least common denominator is 6. So let me multiply and divide by 6. If I do that, 6 divided by 2 is 3 times 1 is 3. 6 divided by 3 is 2 times 2 is 4. 6 divided by 3 is 2. 3 plus 4 is 7 over 2, and that is your answer. Let me do problem number 12. Five sixths minus 3 fourths over 7 eighths. So in this case, let me multiply and divide by the least common denominator, which in this case is 24. So let me multiply and divide by 24. 24 divided by 6 is 4 times 5 is 20. 24 divided by 4 is 6 times 3 is 18. 24 divided by 8 is 3 times 7 is 21. 20 minus 18 is 2 over 21. And that is your answer. Let me do problem number 14. X squared over y squared divided by 3xy. Well, first off, this is the same as x squared over y squared divided by 3x over y. And so let me rewrite this in a slightly different notation. Oh, I should have read the instructions. In exercises 13 through 60, use any method to simplify the complex fraction. So let me rewrite this in the following notation. So let me write, instead of as a division bar, as this division symbol, x squared over y squared divided by 3x over y. And so I can rewrite division as multiplication by the reciprocal. And so the reciprocal is just y over 3x. Y squared divided by y is y. X squared divided by x is x. 3x divided by x is 3. And so I get x over 3y. And that is your answer. Let me do problem number 24. One over x plus 1 over y divided by 1 over y squared minus 1 over x squared. And so let me multiply both sides of my equation by the least common denominator, which in this case is x squared y squared. So in this case, we get one of the x's cancel. 1 times x y squared is x y squared. One of the y's cancel. And so I get x squared y. Both of the y squares cancel, so I get x squared. Both of the x squares cancel, so I get minus y squared. Let me factor out the numerator. I can factor out an xy. What remains is y plus x. I can factor the denominator. It's the difference of squares. X minus y over x plus y. I can cancel. The x plus y divided by x plus y is just 1. And so I get xy over x minus y. And that is your answer. Let me do problem number 28. X minus 1 minus 4 over x divided by 2 over x squared minus 1 over x plus 1. So let me multiply and divide by x squared. And so I get x cubed minus x squared minus 4x over 2 minus x plus x squared. Let me factor out the x that's in common in the numerator. So we get x squared minus x minus 4. Let me rewrite the denominator in descending order. X squared minus x plus 2. I can't factor the numerator. What's in parentheses in the numerator? I cannot find two numbers whose product two whole numbers. So I can't factor over the integers. I can factor maybe over the reals, but over the integers, or at least over the complex numbers. I can't find two whole numbers whose product is 4 and whose difference is 1. Neither can I find two whole numbers whose product is 2 and whose sum is 1. And so I am done. Let me do problem number 30. And so this is x squared minus 9 over 1 over x plus 1 over 3. Okay, so let me multiply and divide this by the least common denominator, which in this case is 3x. And so this is equal to 3x times, let me factor, x squared minus 9 is x minus 3, x plus 3, over the common denominator, well, over, the 3x's, well, divided by x is just 3, times 1 is 3. The 3's cancel, so I get plus x. And well, I can cancel the 3 plus x's. And so I get 3x times x minus 3. Any questions about that? Okay. Let me do problem number 36. X over y plus 2 over x divided by x over y minus 1 over x. So I want to simplify this. So let me multiply and divide by the least common denominator. The least common denominator in this particular case is xy. Let's multiply and divide by xy. The y's cancel, so you just get an x times x is x squared. The x cancels, so all you get is a 2y. The y's cancel, so you get x squared. The x cancels, so you get y. Oh, and you're done. You cannot factor either numerator or denominator. So that's your answer. Any questions about that? Let me do problem number 42. 4 minus 2 over t plus 7 divided by 5 plus 9 over t plus 7. And so I'm going to multiply and divide by, in this case, at least there's only one denominator, t plus 7. So I'll just multiply and divide by t plus 7. So if I do that, well, I'll multiply 4 times t, 4 times 7, and so I get 4t plus 28. The t plus 7's cancel, so I just get minus 2 over, well, I have a 5 times a t plus 7, so let's multiply that out. 5 times t and 5 times 7, so 5t plus 35. The t plus 7's cancel, so I get plus 9. And so you get 4t. 28 minus 2 is 26 over 5t. 35 plus 9 is 44. I can't factor the denominator, so I'm done. You could factor a 2 out of the numerator, but that's not going to give you anything. Let's do problem number 48. Good morning. So let me do problem number 48. Y minus 6 plus 22 over 2y plus 3. Oh, okay. Can you hear me? Uh-oh. I wonder why that's not. Oh, I can. So here, this is being. Okay, wait 1 second. Oh, no. Let me just see something for 1 second. You do not hear me. Yes. Okay. That's unfortunate. Okay. Oh, I'm recording here. Oh, darn. Oh, okay. So somehow I can't do them both simultaneously. Okay. 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 So I will re-record. Yes, it turns out that I guess I will. Oh, but that's that's sort of. Huh. Okay. So I guess I'll re-record this in 10 minutes. So I'll finish off this. You can actually hear this being taped, but I guess I can't do it simultaneously. I'll have to figure out how that I can do both simultaneously. Okay, so let me finish this. I'm almost done with this section, and then I'll have to re-record it on cccconfer.org. So 58, so y minus 5 plus 11 over 2y plus 3. So let me multiply and divide by 2y plus 3. Okay, so let me do that. So first, let me multiply the y inside the parentheses. So I have y times 2y, which is 2y squared. Y times 3 is 3y. Negative 6 times 2y is a negative 12y. Negative 6 times 3 is negative 18. The 2y plus 3's cancel. So you get plus 22 over. Again, y times 2y is 2y squared. Y times 3 is 3y. Negative 5 times y is negative 10y. Negative 5 times 3 is negative 15. The 2y plus 3's cancel, so you get plus 11. And so this is equal to, well, combine like terms, so you get 2y squared. 3y minus 12y is minus 9y. 22 minus 18 is 4. 3 minus 10 is minus 7y. 11 minus 15 is minus 4. And so you can factor this. 2y, y, and a 1 and a 4. So you get 2y squared minus 8y minus y is minus 9y plus 4. 2y. And so you get 2y squared minus 8y plus y is minus 7y minus 4. Let me cancel the y minus 4's, and so you get 2y minus 1 over 2y plus 1. And that is your answer. Let me do problem number 60. X over x minus 2, minus 4 over x plus 1 divided by 10 minus 2x over x squared minus x minus 2 plus 1. And so this is equal to x over x minus 2 minus 4 over x plus 1 divided by 10 minus 2x. Let me factor x squared minus x minus 2. This factors into, well, it's a monic polynomial. So I'll just bring down the x's. I have a negative, so I'll bring down the negative times negative is positive. I want two whole numbers whose product is 2 and whose difference is 1. 2 and 1. And so the least common denominator is just x minus 2, x plus 1. And so let's multiply that out. And so this is equal to, well, the x minus 2's cancel, so you get x times x plus 1 minus 4 times, well, the x plus 1's cancel, x minus 2. The x minus 2's and x minus 1's cancel, so you just get 10 minus 2x plus, well, 1 times x minus 2, x plus 1. So if I multiply the x in the parentheses, the negative 4 in the parentheses, and multiply this out, I get x squared plus x squared plus x minus 4x plus 8 over 10 minus 2x plus x squared minus x minus 2. And so this is equal to x squared minus 3x plus 8 over x squared minus 2x minus x is minus 3x plus 10 minus 2 is 8. And so these cancel. And so you just get 1. And that is your answer. Okay, so let me stop this recording